One of my favorite things to do is to buy cheap embedded devices and look for bugs in them. Typically, embedded devices like routers and IoT stuff tend to have the worst security. It's kind of like a fun exercise in bug hunting. Now, I made a previous video on this little router that was super fun, so I figured why not continue? Why not do more bug hunting? And so I bought this router here. You'll notice that it has 18,000 reviews with over 400 bought in the past month. So this is a device that's very commonly used in people's houses, protecting them from the wild hackers on the internet. Now, this video was supposed to be extremely simple, right? I was just going to make a video on these backdoor passwords that were found in these routers, and that was going to be it. But in the process of trying to make this video, I actually found a different backdoor that's a little more nefarious. It all started when I was looking for that original backdoor. Now, the backdoor originally reported was that there was a password that was unreported that you could use to get into the front page of the router. If you go to the URL or the IP address of the router at your house, typically there's a login page, so you can go in there and set the Wi-Fi password, set the IP address, whatever. And supposedly there was a backdoor secret password that no one knew about that if you could find it, you could get in for free, zero authentication. So I wanted to go check out that password and go find it. To start my investigation, you can just go to the Telnet website and download the firmware for the router, right? This is a thing that you're supposed to be able to download because if you want to update your firmware, they just give you the firmware for free. This is intended behavior. Now, what you can do with these firmware images a lot of the time is do this thing called bin walking, right? Inside of this firmware image that is otherwise kind of just gobbledygook, right? There's a bunch of nonsense in here that I don't know what to do with. I can't really do a ton with this. We can use this tool called bin walk to recursively go through in the firmware image and try to pull data out, right? We're trying to look for the files inside of the image to hopefully reveal this backdoor password. If we go here and do a little bin walk on this firmware image, you'll see that eventually a few things fall out, one being very, very important. We get this thing called a squash.fs file system. This squash.fs root is the file system that lives on this router, right? So what I can do now is go into this binary and find the binary in question that supposedly had the backdoor. Supposedly, the backdoor is in this file called bin httpd, right? So when you go to a router, there is a web server being presented to you, right? Some binary, some program in the router has to present that data, right? So the server in question, httpd, would be the one that has to process the password and therefore would have a backdoor in it if a backdoor was involved. And so what we can do is open up httpd in a framework like Ghidra. Ghidra is a reverse engineering framework where you take the binary that we don't have source code for, and over here is the machine code, right? This is the machine code that the CPU actually executes, the lines of assembly line by line here. And on the right, it has the best guess of the C code, the code that an actual author of this code would write, and it's much more human readable. So inside the binary, I'm going to the form login function. This is a function inside the binary that would process the request to log in. And if any backdoor were to exist, it would exist in this function. And so we see two things start to happen. The first one's very normal, right? Get value sysadmin password. It's comparing this value, the password from the config, to the input from the request, right? We have pcvar1 is the data from the JSON that we sent it, right? That's the password we're sending it. And it says basically, okay, cool. If the admin password in the config matches the given password, okay, cool, we pass, we have a login type admin, not a big deal. But then there's this other one, sysrzadmin. And this is a completely different password that we actually have no way of controlling. Guys, this is the backdoor, okay? This rzadmin was an undocumented password in the 10-to-line of router that you're able to use to log into the router for free, and you cannot change it. So if you know the password, you can get in. So we can search around the squash.fs root for this string to find other places where it's used. A lot of calls to this string in httpd, another one for imsd, not sure what that does. But then this other file caught my eye, default.config, right? What I'm assuming is happening here is these are the default entries to the configuration file of the router. So if the password for the backdoor is going to exist anywhere, it's going to be here. And sure as crap, if we go and we look at that file, if we look for rzadmin, we see 2 lines here. The username for the rzadmin is rzadmin, and the password is here. You will notice there is this really weird pattern in Telnet firmware where for some reason, everything they do, they base64 encode it, and that becomes the password. So we can look just real quick at this string. We'll do a little echo of this into base64 decode, and it ends up being rzadmin0. So I found this string, and I was like, okay, cool. I went and bought a Telnet router for me to showcase this bug off to you guys, right? And lo and behold, if we go and use this password to get into the device, it doesn't work. Also, maybe it just takes a base 64, and this also does not work. Guys, in classic me fashion, I bought the wrong router, okay? This version of the router is not vulnerable to this backdoor. However, that didn't stop me. I'm a hacker. I have to get into this device now. I now have a moral, ethical requirement to hack this device. So in pursuit of my new hack, right, I downloaded a ton of firmware. The one that specifically applies to me is this US AC10 V6. That is the version of this router, right? This is an AC10 V6. And so I wanted to do some more research on this router. Does a different backdoor apply to this router? Is there a different kind of Tenda backdoor in this router? And so what I would do typically to find a bug like this is just like we did with the other router firmware, right? We're gonna bin walk ME on the US AC10 V6. And what you'll see is the only thing that pops out of this device is an OpenSSL encryption blob. For some reason, in this version of the firmwares, they started encrypting their firmware. There is a whole conversation to be had about firmware encryption for a different video, but what that tells me as a researcher is that Tenda is hiding something. There is something on this router that they don't want you and I to see. I highly doubt over the course of one release that their security magically just got better and that they magically just stopped putting backdoor passwords into routers, okay? So I'm now determined, right? I need to figure out what are they hiding inside of this firmware image. Now, like any good hacker, before I went and started doing the actual VR, right, the bug hunting, I went and did some recon. Maybe there's another bug that already exists for this model of router that I can just use to hack into it, okay? And so I want to highlight, guys, how bad these routers are. This is another researcher doing just research on one model of Tenda router, the AC18, and you'll notice that every one of these markdown files is a different bug in the router that is able to be used to get code execution on this router. Now, unfortunately for me, I was not vulnerable to any of these, and the ones that actually did matter were memory corruptions. I would need to be on the router to debug them and land them properly. So this was completely out of the question for me. But my recon highlighted one bug for me that I truly could not believe. This bug is so egregious that I had to try it myself just to be sure that my new router was not vulnerable to it, okay? A vulnerability was identified in Tenda AC20 that if you go to the /goform/telnet route of the HTTP service, it enables Telnet. Literally, if you go to this form without a password, it will turn on Telnet. And sure as shit, if we try to go to the router's Telnet right now, it doesn't work. It is refused. If I do a curl to the IP address /goform/telnet, we will get a response back. And then again, no password, by the way. And then now if I go to Telnet again, the Telnet is enabled. And this is where I hit a hard roadblock, okay? We have a telnet prompt, but it didn't just drop us to a shell. We have to actually now know the root password. The root password contained in a shadow file in the firmware image that is encrypted. I don't have the password, so I guess I'm just stuck. And we can try a few different things. I tried the RZ admin password. I tried a couple other backdoor passwords that were reported, and lo and behold, I didn't have it. Wouldn't it be unfortunate if there's a vulnerability in this router where the root password was calculated by parameters that you can find just by looking at the router, that you could just guess pretty much or deduce mathematically? Tenda AC8 calculated root password. The TLDR here is they take the last two parts of the MAC address of the router, which you can get from an ARP request, so it's literally that's free, and then they concatenate it to this string here, and then base 64 it, and that becomes the root password. Okay, that sounds freaking awesome. So we'll try that real quick. Again, all I have to do is do ARP A to get the MAC address of the router. The last two, they concatenate them with this random string, right? So they take this random string, they do the second to last byte up front, they do the last byte at the bottom, and again, I'll show you the ARP table for the entry here, right? So we have this, the NC00. They concatenate it against this string, and they base 64 encode it. So when I had this, I was like, oh, sure, okay, I've got the password. Here we go. Telnet to the device, root, password, and that's not the password either. So if you read the actual Reddit for this, Tenda is doing this really weird thing where likely every device has a different string, okay? A string that only Tenda knows. Weird that they withhold this information, don't publish it, or like don't talk about it. So if you don't know the string for this data, the string to build your password, you are shit out of luck. And so I sat there for a minute, and I'm like, well, I can't get the string because it's in the firmware, and the firmware is encrypted, so I don't have the string. Circular problems are circular. But then I realized one thing, guys. What do they do after they create this password? For some godforsaken reason, they print it to the screen. Now, on a router, there is no screen, but there is a serial console. I will show you a picture of the setup that I have and leave out technical details. But basically, you can put a serial console port on the router on certain hardware places, and if the console is enabled, you will see the output of the screen, okay? And so what I can do is pull it up right here, and this is the router console. This is it streaming all of the data that are being printed to the screen. I'm gonna blow it up so you guys can see it, right? But this is every time a program on the router prints something to the screen, the data gets put here. It is pushed out to the serial console on the CPU, which is padded out. There are pads for it on the PCB of the router, and I can tap into that and I can read it. And so the theory was, if I hard reset this device, I will catch it live, re-provisioning its password, which will reveal not only the password to Telnet into the router, but also the secret string for this line of routers in general that I will publish to you all for free. So we'll go ahead and hold down the router reset button. This will factory reset the router. And here we go. So it is going through a factory reset right now. Now, again, we are looking for this magical string, step 1. Step 1 is going to be followed by the first part of the string and then the base 64 encoded part after the password. If we can catch that in the output, we can use that to telnet into the device and have root on this thing and then use that hopefully to decrypt the firmware. Now there's a lot of stuff streaming to the screen, so I'm gonna copy this out to a file and then we're gonna Control F for step 1. Guys, and sure as shit, right there is the pre-base 64 encoded password, and then after that is the base 64 encoded string, which is the password because Tenda. So we can use this now, go back, we have to re-enable the telnet because I reset the device. There we go. We'll telnet into the router, root, and there we are, guys. We have a shell on the device. I would show you ID and uname, but we're on a shitty embedded router, so those applets aren't compiled with BusyBox. And here we are. Now, you're probably wondering, what do we do now? We won. We won, guys, right? Well, no. I want to figure out, how do I decrypt this firmware so I can see what they shipped me and how I can use this in the future to do future VR? Well, there is a little binary called decry firmware. Where'd you go? Decry firmware. Likely, this is decrypt firmware. Now, what I'm not gonna do in this video is pull the keys out and show you guys the keys because I don't wanna get sued. But I have them, so there you go. That's pretty cool. I will be writing a blog post with those keys. I have to clear it with my lawyer first, I think, is the game plan, just to make sure I don't get fucking sued. But anyway, the point of these videos, guys, is never to be like, don't use this hardware, don't use this software, there is a bug. It's more like just a kind of a fun like exercise in finding bugs and, you know, talking to you guys, having fun with you guys. But when it comes to this particular brand, Tenda, it's been like 10 years and it feels like every couple of years there's some new breaking story where they accidentally left in some firmware backdoor or some crazy vulnerabilities, plural, by the way. And again, this posted 11 months ago is only on one model of these routers. In my opinion, if you're using these routers, guys, you're doing something a little crazy. Now, if you enjoyed this video, I have another video on this channel that I had a lot of fun making where I found this device on Temu for the low price of $5 and found a similar vulnerability, and the whole journey of how I did that is in this video here. Go watch it. We'll see you over there. Take care, guys.